Next we can see that that is structures, that is isolithobilyanic acid and allolithobilyanic acid. So Windows proposed 4 isomeric acids, that is one is lithobilyanic acid, and that is then isolithobilyanic acid, allolithobilyanic acid, then also isolithobilyanic acid. So these are the 4 types of acids, and in this they confirmed that this on heating, that the first two, that is litho and allolithobilyanic acid, that is this one is iso. Okay, allolithobilyanic acid, both of them are having a same product, that is they are getting pyrolithobilyanic acid, and the last two, that is isolithobilyanic acid as well as isolithobilyanic acid. In both of this isolithobilyanic acid, so in both this isolithobilyanic acid will be getting isolithobilyanic acid, as well as this allolithobilyanic acid they are obtaining pyroalloisobilyanic acid. So from this what they understood is this first this is the sixth structure, sixth one, and this one is the seventh one, and one which is getting in the fifth is, that is pyrolithobilyanic acid, and in this again heated is the lithobilyanic acid, pyrolithobilyanic acid, as well as the that is pyro, as well as the sixth one, pyro isolithobilyanic acid, that is both of this, that is pyrolithobilyanic acid as well as pyro isolithobilyanic acid. Both of them on heating they yield a product known as deoxypyro acid. So what they again undergo, that is the reduction, that is by means of, it is known as Clemenson's reduction on the structure 6, the structure 6 and 5 is known as that is pyrolithobilyanic acid, and sixth one is the pyro isolithobilyanic acid. These two on reduction they are getting a common product, that is pyro, that is known as pyroic acid, that is deoxypyro acid, that is they both we will get deoxy, it can be called as deoxypyro acid. So it is deoxypyro acid means that is this undergo reduction in the double bond O, that is resulting in deoxypyro acid. Although it is called an acid, that is because of the parent name it is given as acid deoxypyro form. This is known as deoxypyro acid. This is a product which is obtained on Clemenson's reduction. This indicates that the formation of this deoxypyro acid as well as the formation of that is pyrolithobilyanic acid. So this indicates that this pyrolithobilyanic acid. So pyrolithobilyanic acid, the structure is this one. It is having a double bond O. That is this kind of double bond O. If it is comes here means it is the that is that forms, that is pyro allo as well as pyro isolithobilyanic acid. So in the case of fifth structure, that is pyrolithobilyanic acid, the double bond comes here and with the usual. Okay, so in this structure that is in the structure, that is pyrrolithobilyanic acid. This indicates that this a compound also obtained deoxypyroic acid. This suggests that here that is the parent compound having the carboxyl group in that is in the cis position. The carboxyl group is on the cis position. So carboxyl group is on the cis position, then only that is this cyclization is occurring. So this is expected that the cyclization is occurring because of the cis configuration. Only because of cis configuration this type of pyrrolithobilyanic acid undergoes cyclization, and because the two carboxyl group are on the cis position, that is they are on the same side. And also the formation of that is also the second means that is allolithobilyanic acid will also yield this pyrrolithobilyanic acid. This also suggests that there is a that is inversion at the C5 position. There may be an inversion is possible on it may be on the carbonyl group, or it may be occurs in the enol form. It may be on the enol structure which is transferred to the keto form, or it can be occur on the that is possibly because on the carbonyl group where this carboxyl group undergoes cyclization. So this carboxyl group undergoes cyclization to carbonyl form, where this inversion can also be occur. Because of that, is a second structure, that is allolithobilyanic acid, can be converted to pyrrolithobilyanic acid. So that's the evidence for suggesting the configuration of the nucleus. So the configuration of nucleus can be suggested by the formation of 4 isomeric that is structures, that is isomeric acids: lithobilyanic acid, allolithobilyanic acid, isolithobilyanic acid, and alloisolithobilyanic acid. And the degradation products suggest that they are having a cis configuration, and also during the cyclization there is a chance of forming an inversion of inversion is usually occurring at the C5 must have occurred. So this can be again be supported by the formation of cis-hydranone. So this structures can be again, that is the configuration of the nucleus can again be confirmed by that is the formation of cis-hydranone. Hydranones. That means that is cis-hydranones and the trans-hydranone forms are available. The cis-hydranone forms are more stable, suggested by the formation of 6 hydranones. 6 hydranones are more stable than trans-hydranone. Cis-hydranones are more stable than trans-hydranone. And also in the structures, that is 6 and that is structure 7, that is the pyroforms of isolithobilyanic acid and alloisolithobilyanic acid. And in these two, the carbonyl group is, the CO group is no longer adjacent to hydrogen at C5. So inversion of enol form is not possible. So in the case of the first two compounds, that is lithobilyanic acid and isolithobilyanic acid, we confirmed that their structure is this configuration, and for that the cyclization is more easy. In the case of this 6 and 7, because the carbonyl groups are no longer adjacent to the hydrogen at C5, so what is happening is the enol keto-enol formation is not possible. That means the inversion is not possible. No inversion. And thus the third as well as the fourth form cyclized products. And also they suggest that that is the fifth compound. Fifth is pyrolithobilyanic acid, and the sixth is pyroisolithobilyanic acid. Lithobilyanic acid. Both these are giving the same. That is, both these structures are giving the same deoxypyroic acid. This indicate the that is the configuration is cis. So in general the configuration is cis. It can be confirmed by this formation of cis hydrogens. That is, cis hydrogens are more stable than that of trans hydrogens. And this structures, that is 6 and 7, indicate there is no longer, that is, inversion is possible. And pyrolithonic acid and isopyrolithonic acid gives deoxypyroic acid. It indicates the presence of cis configuration. So what is lithobilyanic acid? As such, the lithocholic acid is there. Lithocholic acid is a lithocholic acid that is present in the natural bile acid, which is a precursor for lithobilyanic acid. So we are discussing with the compound, that is lithobilyanic acid. Actually, this lithobilyanic acid is a precursor form of lithocholic acid, which is a bile acid, and isolithobilyanic acid. So from that also we can confirm that the configuration is cis. So that also suggests the configuration is cis. So the configuration is cis based on the inversion. The configuration is cis based on the product we are obtaining, that is pyrolithobilyanic acid, and also the pyrolithobilyanic acid and pyroisolithobilyanic acid gives deoxypyroxy acid, which also indicate the configuration is cis. The further the configuration is cis is confirmed by the natural, it is compared with the natural bile acid. So the natural bile acid, that is lithocholic acid, which is a precursor for this lithobilyanic acid, that also suggests the configuration is cis. So this is possible only the configuration is cis and the fusion is by cis A by B fusion. That is, the A and B rings are fused together and they are arranged in a cis configuration. So their same group are on the same side of the ring. That is known as cis configuration. The groups are arranged on the same side, and if it is on the opposite side, then we will call it as a trans. Also, the cis configuration can also cis configuration with the A by B fusion can also be confirmed by that is 5-beta cholesterol. Another example is the presence of 5-beta cholesterol. 5-beta cholesterol, that is called as coprostain. It also indicates that the compound is having a cis A by B fusion. Compound is having cis A by B fusion is the compound that is present. So this all indicate that it is having a cis A by B fusion of configuration is expected for all these compounds. Next we have to solve in the that is stereochemistry of that is a configuration of nucleus. First thing we will assume that is the configuration is cis with respect to the A by B fusion. So the ring A and B is fused by means of cis configuration. Next we have to confirm the B by C fusion. B by C, that is the B and C rings are fused together. That we have to confirm. So next thing we have to understand is by the B by C ring fusion. So the B as well as the C rings are fused together. That we have to confirm. And by means of X-ray analysis, so X-ray crystallography and X-ray analysis, we confirmed that the B and C rings are fused by means of trans manner. So in the first thing we understood that the A and B rings are fused by means of cis configuration, whereas the B and C fusion is by that is trans manner. That means through X-ray crystallography it is transformed. And this indicated that this also suggests that the steroid is having a flat structure. Steroid is having flat structure. Then only this B by C fusion will be transformed. And also that is the B by C, the natural compounds with respect to the all natural steroids, that is all natural steroids are having this B and C rings in transfusion. B and C rings, BC ring fusion is by transform. That also confirms that the B and C fusion is ring fusion is that of trans. And in the case of A and B, it is by means of cis, and B and C is by means of transform. And it can be evidenced by an experiment that by Winlands et al. And he shows that the C by D rings have transfusion in sterols and bile acids. So this can be, the evidence is by the scientist Winland. That is Wieland, not Winland, Wieland. Wieland et al. And his co-workers has found that in 1933 shows that the ring C by D. So we are having A, B, C, D ring system. Of this, the A and B are fused by means of cis configuration, and the B and C by means of transform. So to suggest the B by C fusion, the Wieland et al. Give and shows that the ring C by D fusion have transform. They are also in trans manner fusion in sterols and bile acid, because the C and D ring fusion is trans in sterols, that is in natural sterols. This is of transform, as well as in bile acids. They are in transform. That also suggests the B by C ring fusion is a transform, as well as the C by D ring fusion is of transform. And here is an example. So this is evident by that is a degradation of, next one is a degradation. Degradation of what? Degradation of deoxycholic acid. Deoxycholic acid. Degradation of deoxycholic acid. That is 9. That is this is the deoxycholic acid. Are indicating that the substitution is there. Deoxycholic acid. So there is 2 hydroxyl groups are there, and they will be giving that is degradation of deoxycholic acid will give, that is structure, that is extension of the structure is not shown here. COOH H. So this type of compound, that is the 10th compound, is readily not undergoing that is anhydrides. These compounds are not readily formed anhydride. Anhydride. The anhydride was obtained on heating with the vacuum, and after hydrolysis formed that is about another compound, that is this compound, that is known as deoxycholic acid, which will give the compound that is this is the 9th compound and this is the 10th one. And this does not give hydride readily, and the hydride was obtained, that is this hydride was obtained by heating and vacuum is applied, and after hydrolysis to form the corresponding compound, that is So this will give the structure 11 and structure 12. So this indicates that what this is from this what we understood that the compound anhydride was obtained. This compound does not, that is this deoxycholic acid does not readily undergo to form that is an anhydride form, but on heating and hydrolysis and application of vacuum we can obtain this structure, that is anhydride form, and which was different from this compound, that is it is having two carboxyl group, this is carboxylic group, here it is having one carboxyl group, and this anhydride, that is anhydride, and this acid must have, this is possible only when this is in the cis configuration. So C and D have trans configuration. So what we understood from this point is that is the deoxycholic acid will give an anhydride not readily. So it will get only this anhydride when it will be converted to that is by means of hydrolysis as well as vacuum and heat, only this compound is converted to an anhydride form. If it forms an anhydride, that means that is to form anhydride and then it is converted to an dicarboxylic acid form. This readily represents that is this one is directly converting to an anhydride, that means it is having a cis configuration. This is not readily formed, that understood that the configuration of C and D ring fusion is of trans. So their configuration is trans deoxycholic acid. Then this trans C by D fusion is occurs in most steroids except in the case of cardiac glycosides, cardiac glycoside, where the configuration is cis. So most of the naturally occurring steroids, the configuration that is possible is about that is trans configuration, but in the case of this cardiac glycosides only the configuration is in cis form. That's the evidence of that is the ring fusion, that is C by D ring fusion with respect to B by C ring fusion.